Okay, now we're going to talk about integrals of trig functions. Integration is the opposite of differentiation. If you know that the derivative of sine of u equals cosine of u times u prime, which this time I'll write it as du dx. If you have that, well then the integral of cosine u must equal sine u. The integral of cosine u du must equal sine of u, of course, plus c. Since the derivative of cosine of u is equal to negative sine of u prime, I can multiply both sides by negative. The right side will become plus, and the left side will become minus. That is, the derivative of negative cosine of u equals sine of u. Well, that tells you the integral of this equals that. The integral of sine of u du is negative cosine of u plus c. We know that the derivative of the tangent of u is equal to secant squared u du dx. This tells me the integral of this equals that. Or I should say the integral of this times du is equal to the tangent of u plus c. You need to know that one. We know that the derivative of secant of u is equal to secant of u tangent of u times the derivative of u. That means the integral of this du equals that, plus c. The integral of secant u times tangent u times du is secant of u plus c. We know that the derivative of the cosecant of u is equal to negative the cosecant of u times the cotangent of u times the derivative of u. This minus we can put on the other side and multiply both sides by minus 1. This tells me this integral du is equal to negative cosecant of u. The integral of cosecant u times cotangent u times du is negative cosecant of u plus c. Just like before, I ran out of room for the last one. Let's try to get it between the first and the second one. Going to sneak it in right here. Since the derivative of cotangent of u was negative cosecant squared of u times du dx, multiplying both sides by negative 1, we get that the derivative of negative cotangent of u is cosecant of u du dx. That is the integral of this times du, du because it's in terms of u, is equal to negative the cotangent of u plus c. You must know, for at least this section, this right here. You also need to know the left-hand side as well. In fact, if you just memorize one of them, you can easily get the other one. For example, just looking right here, I know that the derivative of tangent of u equals that. The derivative of secant u equals this. The derivative, think of the minus on the other side. The derivative of cosecant of u is negative cosecant of u times cotangent of u. You don't have to memorize all 12 of these. If you know 6, and if you know one of the 6, the left 6 or the right 6, you should be able to convert back to get the last 6, the 6 you didn't remember. Okay, let's do a couple. Remember that the integral of cosine of u du is equal to the sine of u plus c. We know that. So if I ask you what's the integral of cosine of 3x squared times 6x dx. You should call the angle u. Let u equal the angle. The only time you wouldn't let u equal the angle if the angle was x or y or z. But since it's more complicated than just x or just y or just z, we call it u. If u equals 3x squared, well then du is very similar to the derivative, except the dx goes up here. Remember, if that's u, well then du dx is 3x squared. This can go up on top. At least it is much more complicated than just saying this times this equals that. But it does work in this case. It does work. Du equals 3x squared dx. And I did make a big mistake. Du dx was 6x. Du dx was 6x, and bring the dx up there. Okay, so just looking at the information here, I now know that 3x squared is u, and I now know that 6x dx is du. So I have cosine u du. Cosine u du. But that's one of the things I remembered. The integral of that is sine of u plus c. Now just substitute back what u was, and you'll be done. And don't guess. I see so many students guessing, oh my, what is u? I don't, it's right here. It's right here. U equals 3x squared. You can always replace equals for equals. Okay, so that one is done. We know that the integral of secant u times tangent u times du is equal to secant of u plus c. This is something that we just know. So if you're asked, well, what's the integral of secant of x squared times the tangent of x squared times x dx? Again, whenever you have trig functions, 99 out of 100 times is correct to let u equal the angle. Never ever let u equal the angle if the angle is just x or y or z. But ruling out the case where the angle is either x or y or z or k, ruling out that case, 99 out of 100 times you should still let u equal angle. Every once in a while it would not have been the correct move. So So you let u equal the angle. So then du is very similar to the derivative of x squared, except the dx goes up here. So this here, I'm going to say is secant of u. This x squared is u. Times the tangent, this is u. Now, if I only had a 2 here, then 2x dx is du. But if I put a 2 in the numerator, which I did, I have to bring out its reciprocal. So now this integral is 1/2 the integral of secant u times tangent u times du. But this is good. This is good, because as a Calc 2 student, you just need to look at that and say, I know what that is. That's secant of u plus c. Need to know that. And u is, in this case, x squared. So there's the answer. You do not have to put those parentheses. But you could. Now, there's some more that you should know. For example, I never told you what the integral of tan u du was. I never told you what the integral of secant u du equaled. I never told you what the integral of cotangent u du equals, nor did I tell you what the integral of cosecant u du equals. The integral of tangent of u, if I remember right, that's negative ln of cosine of u plus c. The integral of secant of u is also an ln. It's ln of secant u plus tangent u, of course, plus our constant. The integral of cotangent u is negative ln of sine of u plus a c. Okay, the integral of cosecant of u, well, that's going to be negative ln of secant becomes cosecant, and tangent becomes cotangent. Okay. These are the harder ones. You need to know those. You need to know these. And if you wanted to check it, you would take the derivative of this and you would get tangent u. You would take the derivative of this and you would get secant u. Even if you included the constant, remember the derivative of a constant is 0. The derivative of that will be cotangent u. And I'm sure I'm right, but you to show me that I'm wrong, you would show that when you take the derivative of this, you don't get cosecant of u. And I would say, okay, you're right, very good. But they're correct. You need to know those answers. It's a lot of memorization. But then again, that's that's easier than doing a lot of math. Okay, so if you're asked to do the integral of x cosine of x squared dx, well, if that's u, then this is cosine of u. Let u equal x squared. Well, that clearly, so that's cosine of u. And what's left over? X dx. Up to a multiple, you want that to be du. Well, if u is x squared, then du is 2x dx. We have the x dx, we just don't have the 2. Oh, but a 2 is a constant. You can put a constant in, you can't put a letter in. If you put a 2 in, then you have to bring out a half. Well, then this piece is cosine of u, and that piece is du. So we're in the form 1/2 the integral of cosine u du. There's the half. You're supposed to know this integral like you know your name. It's sine of u plus c. And u happens to be x squared. And there's the answer. And you can take the derivative of this, and you should get back this. Let us check. The derivative of this. Well, the half just stays there. And multiply the half by the derivative of this. The derivative or sine of any angle is the derivative of the angle times the cosine of that same angle. A half times 2 cancels out to 1, and you're left with this. That is x cosine of x squared, which is exactly what we wanted. There's no way we're wrong. Okay, let's try another one. Okay, how about this problem here? The integral of the secant of x cubed to the 5th power times secant of x cubed times tangent of x cubed times 7x squared dx. Most probably you would see the 7 there, but in either case you should factor out the constant. And like with any trig function, you should try to start off with letting u equal an angle. So this is, and then du will be 3x squared dx. So this will be secant of u to the 5th power. I'll put the 5 there. Times, this will be secant of u, and this here will be tangent of u, and the 7's no longer there, we put it in the front. X squared dx, that's almost du. If I sneak a 3 in the top and I divide by 3, that's okay. I can sneak this 3 in. Now this here is du. Okay. Now some integrals require a second and possibly a third and very rarely a fourth substitution. If I let v equal secant of u, then dv, the derivative of secant of any angle, is secant of that angle times the tangent of the angle. times du. This here is my dv. And this here is u to the fifth. So this was not a trig integration. It was something's a little bit wrong. It's not u to the fifth, but v to the fifth. This is really v, that's how I define v, to the fifth. So, and we had to divide by the 3. Let's not forget that. So what we have is 7/3 the integral of v to the fifth times this, which is dv. Well, I know that integral. That integral is an easy one. The 7/3 stays. The integral of v to the fifth is going to be v to the sixth over 6 plus c. That is, it's 7/18. 3 times 6 is 18 times v to the sixth plus c. Well, what's v? V is secant of u. Secant of u. But what's u? X cubed. There's your final answer. 7/18 secant cube of x to the 6th power plus c. That's your final answer. It used 2 substitutions. Many times when you have trig functions and you let the angle equal u, you might have to make a second substitution. You were asked to find the integral of the secant of 1 minus x times the tangent of 1 minus x dx. I gotta keep advising you, let u equal the angle. The angle is 1 minus x. So then du will just be negative dx. Well, we clearly have the dx. I mean, I see it. There's the dx. I'll put the minus in. That means minus 1 I put in. I have to put a minus out in front. So right now, we have negative, the integral of secant of u, because that's what I'm calling u, times the tangent of u, times the tangent of u, times negative dx. Oh yeah, negative dx is du. Just don't say, oh, that's du. Make sure it says it, du. Well, you're supposed to know the integral of secant u du, the integral of secant u tangent u du. The minus I just wrote down is that minus. This integral is just secant. Remember, the derivative of secant is this. Alright, and then we plus c, and then we just substitute back. U is 1 minus x plus c. If you take the derivative of this, you will get this back. And if you don't, find your mistake. Let me try some more. How about this one? The secant of 2 theta minus the tangent of 2 theta all squared, and we want the integral of that times d theta. Well, like I've been saying, let the angle, which is 2 theta, equal u. Well, then du will be 2 d theta. Well, I see the d theta. If I have put a 2 in, then there's no doubt about it, that's du. Because of that symbol right there. It says du is 2d theta. But if I put a 2 in, I have to bring a half out in front. Okay, so now we have 1/2 the integral of secant u minus tangent u all squared times 2d theta, which is du. Now I would square this. I would square that out. I possibly would simplify it first. Secant of u is 1 over cosine u minus the tangent of u is sine u over cosine u. We want to square that. But since the denominators are the same, let's denote that. You have cosine u on the bottom and 1 minus sine u on top. That's what's in between the brackets. And we square it. Well, the top is going to be 1 minus 2 sine of u plus sine squared of u. And this is all over cosine of u. Okay. So this is equal to 1/2. This piece we said is 1 minus 2 sine u plus sine squared u all over cosine u, and don't forget to multiply by du. So this is many integrals. In fact, it's 3 integrals. The integral of a sum is the sum of the integrals. That is, the 1/2 I can factor out. It's the integral of 1 over cosine of u du minus the integral of 2 sine u over cosine of u, but I'll pull a 2 out in front, times du plus the integral of sine squared u over cosine u times du. Okay, this is a harder one. On the side here, let's work on some of them. You have 1 over cosine u du. But 1 over cosine is cosecant u du. And we're supposed to just remember what that integral is. The integral of cosecant u du is negative ln of cosecant u plus cotangent u plus some constant. So 1/2, this first integral is negative ln of the absolute value of cosecant u plus cotangent u plus some constant. Okay, so we did the first integral, and I'm going to erase the work. And now we're going to look at the second integral. Okay, minus, now that 2 is just going to stay. It's going to be 2 times whatever I get for that. The integral of sine u over cosine u du. If I call this u, okay, I already have u, so I'm going to call it v. If I call that v, if I let v equal cosine of u, that is, the bottom is v. I want dv on top. That would make it an ln problem. dv is negative sine u du. Well, the top is almost that. If I only put a minus in front, I'll have du on top. But if I put a minus inside the integral, I have to take one out. So there's a minus in front. Minus sine u du is dv. But that integral I know. There's a minus in front. That integral I know. It's ln of v, where v is cosine of u. And u was 2 theta. So it's minus 2. Also, it has another minus, so it becomes plus 2 ln of cosine of 2 theta. I'm going to go back to the first part on the bottom, and I'm going to change the angle of u. U was 2 theta. We made that substitution. U is 2 theta. Okay, plus this new integral. Now the new integral is going to be the harder one. Now, one of the things I didn't like about my Calc 2 teacher is he being a bright person, bright guy, he never, ever, even once made the wrong substitution. And of course, my not being so bright, I would go home and I would always make the wrong substitution. And I never got to see in class how you tell if you made the wrong substitution, what do you do when you make the wrong substitution. Now, if I call this bottom v, the derivative, then dv would be negative sine u du, not sine squared u. I taught you in Calc 1 to usually let what's being raised to the power to be u. In this case, v, because we already used up u. Well then, dv would be cosine u du. Well, this piece would be v squared, but I have, what I have left over is du over cosine u. I don't have that. It didn't work. It didn't work. Okay. So then, what do? You have to make another substitution, or rewrite the problem differently. We know that sine squared plus cosine squared is 1. Bringing the cosine squared over to the other side, we now know that instead of sine squared u, I can write 1 minus cosine squared u over cosine u du. So it's 1 over cosine u minus cosine squared u over cosine u times du. Ran out of room for that. But I can integrate these separately, and I can even clean them up. 1 over cosine u is our secant of u minus cosine u over u, cosine squared u over cosine u is just cosine u. Both of these I know how to integrate. I meant to write du, not dx. The first integral is ln of secant u plus tangent u minus the integral of cosine u is sine u. So it's minus sine u. Now, the comment I'll make is, to make life a drop easier, I already had one integral of 1 over cosine u du. So now I have another one. So I'm just going to come in the front, and it happened to be a minus. Now I'm going to say minus 2 of them. It used to be minus 1 of them. Now it's minus 2. So something's bothering me. I think what's bothering me is when I first did this one on the side, I said 1 over cosine u du is the integral of, possibly I wrote cosecant. If I did, I was wrong. But in either case, the answer is ln of secant u plus tangent u. Sorry about that. So the minus goes, and this becomes secant, and this becomes tangent. Hope I didn't confuse you too much with that error. Okay. So we dealt with this because we already have it. I put a 2 in front. Now I need to take away the sine of u. But u was 2 theta. And there's your answer, plus some arbitrary constant. Not the friendliest of problem, but nonetheless, there's your answer. Okay, need to be able to do that. That would not be a nice problem on an exam. But the bottom line is, if you can do the ones that are hard enough not to be on an exam, well then you're going to be able to do the ones that are on the exam. Let's do something else in this section. So now you could it can be a definite integral. Suppose you have the integral of the sine of 2x dx, and you're going from 0 to pi. Again, let u equal the angle, 2x. Well then du will be 2 dx. Well, you have the dx, you just need a 2. If you put a 2 in, then that's du. But if you put a 2 in the top, you have to put a 2 in the bottom. Put a 1/2. And this becomes 1/2, that's sine, integral, sine, that's u, and 2x dx is du. Ooh, I know that integral. It's negative cosine of u. Now, you have 2 choices. We'll do it both ways. You could put back what u equals 2x, and then go from 0 to pi. Now, I hate negatives in front. If I ignore that negative, which I'm allowed to do, provided I interchange those limits. Don't change the signs of them, just change their location. And I'll factor out the half. First I plug in 0. 2 times 0 is 0. So it's the cosine of 0 minus the cosine of 2 times pi. Both of which happen to be 1. Both of these are 1. And 1 take away 1 is 0. And a half times 0 is still 0. Another way of doing this is immediately don't convert back to the x's. Change the limits though. These are x values. Those are x values. You have to decide. When x is equal to pi, what is u equal? Well, u is equal to 2 times x. And I'm telling you what x is, it's pi. So u is 2 pi. That's the upper limit, 2 pi. And the lower limit? The lower limit is when x is 0. When x is 0, u is equal to, here's the rule to convert u to x's. Double x and you get u. to get u equals means to get. To get u, compute 2 times x. U is equal to 2 times 0, or 0. So the lower limit is 0 and the upper limit is 2 pi. Switch the limits, because I just hate negatives in front. 1/2 cosine of u from 2 pi to 0. Factor out the half. And notice, I'm going to get exactly what I have on the bottom. Factor out the half. You have cosine of u minus cosine of 2 pi. Both of these equal 1. 1 minus 1 is 0. A half times 0 is 0. Now, so why did we get 0? Well, the reason we got 0 is the sine of 2x goes like this between 0 and pi. This area, whatever it is, it equals that area. But this area is negative. That is, if this area was 13, then that area is negative 13. When you add them up, you do get 0. So it would have been really slick if you caught that from the beginning. Okay, sometimes you just draw the graph and you go, oh, it equals 0. And you didn't have to do anything we did. You should always try to see what the problem is asking. And if it's a trig function, you can draw it. Well, sometimes you can. If it's a nice simple sine curve, from 0 to pi or 0 to 2 pi, things like that, you know how to graph. Take a look at it. Maybe you'll see the answer. Okay, let's just try one more. Suppose you have well, actually, why don't we do this one twice? Suppose you have this integral. Now, there are 2 ways of doing this. Now, I'm not going to let u equal an angle, because if I let u equal x, then du equals dx, and this becomes the integral of the sine of, well, x is u, and x is u, and dx is du. We didn't get anywhere. We just changed from x to u's. We didn't get anywhere. So we never substitute, we never let the angle equal u when the angle is x or y or z or a or b or alpha or beta. Okay. What you might realize is the derivative of this is cosine x. So the differential of u, which is du, would not be cosine x, but rather cosine x dx. It's a big word, differential. You put the dx up here, you call this differential. You put the dx underneath, then you call this derivative. That's the big thing there. Differential, derivative. Okay, so this is u, and all of this is du, and let's not forget the integral sign. Well, think of it as the integral of u to the 1 du. That's the simple one. That's just u squared over 2 plus a constant. U is sine of x, so it's sine squared x over 2 plus a constant. That's one answer. That's one way of writing the answer. But you know what? I don't like that substitution anymore. I don't like that one. Well, somebody else does it. They make the substitution that u is cosine x. That's u. So let's just write it first. That's u. And what's left over, namely sine x dx, we would love up to a multiple, because we can put any constant we want, that's du. Well, du is negative 1 sine x dx. That is, we just need a minus. Okay, I put a minus here. So now this is du, and this is cosine of u. If I put a minus inside the integral, I have to put 1 in front of the integral. And now this is going to give us, writing it down here, negative the integral of cosine u du. But the integral of, let's see what happened here. Okay, so the integral of cosine u du is sine of u. Something's disturbing me. Did I do the first one wrong? Oh, excuse me. We're calling cosine x u. We're calling cosine x u, not cosine of u. We're calling cosine x u. So we have negative the integral of u du. But that's negative u squared over 2. That is, it's negative u squared over 2 plus e, where u was, says it right here, u was cosine x. And like I did on the line above, I won't put the square there. Not the line above, but the answer above. But rather, I'll put their square here. Now, the thing is, these two answers, they do not look the same. They do not look the same. Okay, but they differ by a constant. This is C1 and this is C2. Let's look at the top answer. Remember that bottom left, sine squared plus cosine squared is 1. So if I bring this over to the other side, I get that sine squared is 1 minus cosine squared. So this top answer, instead of sine squared, I'm going to write 1 minus cosine squared x all over 2 plus a constant, plus C1. But this is where we get the bottom line. 1/2 is just a constant. And when I add it to C1, I get C2, a different constant. And then I have to take away cosine squared x over 2. But that's exactly what I have down here. That's exactly what I have down here. This answer and this answer, they're the same. They are the same. C2, the constant on the bottom, is 1/2, this 1/2 here, plus C1, plus C1. It's just a different constant. Okay, so they differ by a constant. The bottom one, the C2, is a little bit more than C1. It's a half more every time. If C1 is 7, then C2 is 7.5. If C1 is 10, then C2 is 10.5. They just differ by a constant. If you subtracted them, they would differ by a constant. Okay, that finishes the lecture on trig integrals.